Okay, we're ready to start our new chapter. Chapter 6 is our radical chapter, and it's going to be really radical. So, we're going to start with square root. So, we're going to learn actually all the roots: square root, cube root, fourth root, fifth root. So, that's why we call it the nth root. But we're going to start with square root because it's the easiest one. The first time I made this video, the sound didn't come out, so I have it filled out. So that's why I'm covering part of it up. So the definition of a square root is if a number is a square root, then if I square that number, I should get the number back. So most students know 3 is the square root of 9. And according to that definition, that means 3 squared is 9. But according to that definition, guess what? Negative 3 is a square root of 9 too, because doesn't negative 3 times negative 3 give us positive 9? Yes, it does. So every positive number has 2 square roots, a positive square root and a negative square root. And that's what this first thing says. All positive numbers have 2 square roots, one that's positive and one that's negative. So the square root of 9 is positive 3. The square root of 9 is negative 3, according to that definition. Okay, so there's 2 square roots for every positive number. 0 only has 1 square root. Square root of 0 is just 0. Negative numbers don't have square roots, because if I said, what's the square root of negative 9? And we're going to learn later they have imaginary square roots, but they don't have any real square roots. So what you should ask yourself is, what number times itself gives me negative 9? And some students will go negative 3. No, negative 3 times negative 3 is positive 9. So when we get a negative under a square root, we just write non-real number, because it is non-real. We're going to learn at the end of this chapter the square root of negative 9 is actually 3i. It's an imaginary number. The reason it's non-real is because no real number times itself can give me negative 9, because when I take negative 3 times itself, I get positive 9. So let's go down here and square root of 25. So they said every positive real number has 2 square roots. Hence, square root of 25 is negative 5 and positive 5. Square root of 16 is negative 4 and positive 4. Square root of 49, negative 7 and positive 7. Square root of negative 4, remember, no number times itself will ever give me a negative. No real number times itself will ever give me a negative. So when you are asked to take the square root of a negative number, for right now, since we haven't learned the imaginary numbers, you just write non-real number, which is a true statement. An imaginary number is a non-real number. So when we use the square root symbol, so on this first one, notice how we use words. When I ask you for the square roots without using the symbol, it wants both of them. But when I use the symbol for square root, which is this little radical sign, I only want the positive answer. And we call that the positive square root or principal square root. So in order to get a negative 3, I have to put a negative out in front, and this would be read the opposite of the square root of 9. So anytime the radical is used, not words like up here, Notice the difference. I want you to make sure you understand the difference. So this was asking for square root using words. If they use the symbol, we only give the positive answer, because that's called the principal square root. So if you want a negative answer, you have to put a negative in front of it. And this is the negative square root of a, like I said. I'd rather have them say the opposite of the square root of a, but negative square root of a, that's okay too. And then remember, 0 just has itself, right? So square root of 0 is 0 whether you use words or you use symbols. So in words, we want all the square roots, the positive and the negative. When we use a symbol, that means only give me the positive answer. So why don't you go ahead and shut off the video and try the problems on number 2, and then turn the video back on and we can check those together. Okay, so the first one is, let me get another piece of paper. So the square root of 25 is just 5. Don't write plus and minus 5 because now they're using the symbol. That means they only want the positive answer. Square root of 0.81, and I put the 2 in to show you that when there's no number in the radical, there's an imaginary 2. We usually don't write it, just like we don't write 1x because we know the number in front of x is 1. But when we're doing square root, we usually don't put the 2 in there. We just leave it empty, but you need to know that means there's a 2 there. That's why we say, what's the square root of 25? So the square root of 0.81. We know the square root of 81 is 9. This is 2 decimals, so that means we have to have 1 decimal. And we should learn how to do that on the calculator too, in case it's a really ugly number that you can't do in your head. So square root key is right above the squared key. See that? And see how it's an empty radical? Like here, there's an x in the little crook. Here it's empty, so that means square root. So if I wanted to do the square root of 0.81, I do second square root, whoops, turn on the calculator, Norris. So second square root, and it's second because it's above a key. So anything in the blue, anything above, you have to access using the second. And then you type in 0.81, close your parentheses, and that gives us 0.9. Like I said, though, you should be able to do these without a calculator because you're going to have tests in the next class where you can't use calculators. So unless the numbers get really big, I would definitely do it without a calculator. Okay, next we have the opposite of the square root of 36, which is 6. The opposite of 6 is negative 6. And when you're doing fractions, as you can see, this is called the quotient rule. We're going to learn more about it later in this chapter. You can take one radical and write it as 2. So this is the same thing as square root 4 over square root 25. Square root of 4 is 2. Square root of 25 is 5. And that can also be done on the calculator. So notice when the calculator gives us a decimal problem, we give a decimal answer. When the calculator gives us a fraction problem, we give a fraction answer. You're not supposed to mix units, so make sure you stay consistent. Decimal, decimal answer. Fraction, fraction answer. So since I know this wants a fraction answer, I need to use the fraction bar when I do it. So we do second square root, so second x squared, and then we do 4 fraction bar 25. If I hit divided by, division, remember, gives me decimal answers. I don't want a decimal answer, I want a fraction answer. So 4 fraction bar 25 gives me 2/5, and I can verify that. For the next one, we have the opposite of the square root of 1/9. So that would be the opposite of square root 1 over square root 9. Square root 1 is 1, square root 9 is 3. So that makes that answer negative 1/3. Square root of negative 4. So what number times itself gives me negative 4? No real number, because negative 2 times negative 2 is positive 4. So I hope you wrote non-real number for that, because we cannot take the square root of a negative number, not with the real number system. Square root of 1 is itself 1. Well, the cool thing about 1 is it's everything. The square root of 1 is 1. The cube root of 1 is 1. The fourth root of 1 is 1. The fifth root of 1 is 1. So 1 is everything. And 0, same thing. Square root of 0 is 0. Cube root of 0 is 0. Fourth root of 0 is 0. So 1 and 0 are their own square roots, cube roots, and so on. Okay, so now we're going to extend our definition from above. So we did a square root definition above. Now we're going to do an nth root. So if b is the nth root of some number, then that means if you raise b to that power, you should get that number back. For instance, if you're asked for the cube root of 8 and you write 2, according to this definition, that means 2 to the third should give you 8 back. So that's what cube root means. If I write a number, then if I raise it to that power, I should get that number back. So square root of 9 equals 3. That means 3 squared equals 9. Cube root of 8 equals 2. That means 2 cubed is 8. So here's a couple more examples. 2 is the square root of 4 because 2 squared gives us 4. Oh, funny. Same. Never mind. I did the same example that was given. So super, super, super important is vocab, because we're going to talk about even index, odd index, what the radicand can be, what it can't be. So you need to know your vocab. So the number in the crook is called the index, plural indices. So I could say when the index is even, then the radicand must be positive. So that's the kind of stuff you're going to hear. So you need to commit these to memory. So the number in the crook is the index. The number under the radical is called the radicand. And as I said above, if the index is left out of the problem, that means we can assume it's a 2. It's a square root. Okay, let's go ahead and look at page 2. Okay, I've circled some of the powers that you should have memorized. So these should be sight numbers. So when you see 8, you should know the cube root's 2. When you see 27, you should know the cube root is 3. When you see 64, you should know the cube root is 4. When you see 125, you should know the cube root is 5. Fourth powers, I would just say maybe the first 3. So the fourth root of 1 is 1. The fourth root of 16 is 2. Fourth root of 81 is 3. And maybe just the 2 fifth powers. This one is so common, knowing that 2 to the fifth is 32. So you see that one all over the place. So the fifth root of 32 is 2. That means that 2 times 2 times 2 times 2 times 2 gives me 32. And 1, like I said, is its own power. So 1 is the square root of 1, 1 is the cube root of 1, 1 is the fourth root of 1, 1 is the fifth root of 1, and so on. So those are the ones that I would memorize. I would highlight them and write memorize there. And you'll be so happy you did, because you won't have to be picking up your calculator all the time if you have the major ones memorized. So if we have an even index, remember the answer has to be positive. So an even index, positive answer, and we can only have a positive under the radical.